Hello, viewers. In today's session, we are going to discuss another very important problem from definite integrals. And in this class, we are going to discuss this integral that is from 0 to 2 pi, and the integrand is sine x raised to 10. Right? So let us see how we can easily find out the value of this definite integral using an important property of a definite integral, right? So let us apply the properties of definite integrals to this one, and then we'll apply the concept of beta and gamma functions, right? So let us first call this integral as I, right? Now here we'll apply the property that is integral 0 to 2a, and here we have f of x and dx. So the value of this integral is given by 2 times the integral from 0 to a f of x dx, right? Provided here we have the condition that is f of 2a minus x should be equal to f of x. So here we have this important property that is integral 0 to 2a f of x dx can be written as 2 times the integral from 0 to a f of x dx, provided we have this condition. So here let us take the integrand as f of x, that is sine uh, x raised to 10, right? And here if we compare this integral with this one, then the value of a is given as pi. So this integral is exactly of this form. So we can now write here 2 times the integral from 0 to a. So here we have 0 to pi, and here we have sine 10x and dx. And let us now verify this condition. So now here we have f of 2a minus x is equal to f of 2 pi minus x, because a is equal to pi, and f of 2 pi minus x can be obtained by replacing this x by 2 pi minus x in this function. So we have here a sine 10, and here we have 2 pi minus x, and from trigonometry we know that sine 2 pi minus theta is given by minus sine theta. So here sine 2 pi minus x is equal to minus sine x, right? So here we have minus sine x raised to 10, and here we have the even power. So here minus 1 raised to 10 is simply plus 1. So we are left with the sine x raised to 10, and this is our function f of x, right? So we have seen that f of 2a minus x is equal to f of x. So this condition is fulfilled, right? So now we have this expression. Now again let us apply this property. So we can now write this integral as 2 times the integral from 0 to 2 times pi over 2, and here we have sine x raised to 10. Now the purpose of writing this integral in this form is to convert this integral into this form, that is 0 to pi by 2, and here we have sine uh, px, and then we have cos p, here we have q x, that is equal to gamma p plus 1 over 2. Here we have gamma q plus 1 over 2, and we have here 2 times gamma p plus q plus 2 over 2. right? So here we are now writing this integral as 0 to 2 times pi over 2 sine x raised to 10, because here we can cancel this 2 and this 2 and will again get the same integral, right? So now if we compare this integral with this one, then we can see that the value of a is now equal to pi by 2, right? So now we can again apply this property to this integral, right? So we have here 2, this 2, and then we have 2 times the integral from 0 to a. So now in this case the value of a is pi by 2, and here we have sine x raised to 10, right? And here again let us see whether this condition is satisfied or not, right? So now we have our function f of x as sine x raised to 10, and the value of a is pi over 2. So now f of 2a minus x is equal to f of 2a. A is pi by 2, so 2a is now simply a pi. So we have pi minus x. Now f of pi minus x can be obtained from here. So we have sine pi minus x, and here we have the power 10. Now again from trigonometry we know that sine pi minus theta is equal to sine theta, right? So here sine pi minus x is sine x. So we have simply sine x raised to 10, right? And this is our function f of x. So we have seen that f of 2a minus x is equal to f of x. So we can apply this property to this integral. So now here we have 2 times 2 is 4, and here we have the integral that is 0 to pi by 2 sine x, and here we have 10 and dx, right? So from this discussion we have seen that we have now reduced our integral I into this form. Here in the original integral the upper limit was 2 pi, and due to this property we have now the upper limit as pi by 2. So now we have converted or reduced this integral into this form, and this integral is now of this form, that is 0 to pi by 2 sine x raised to p cos x raised to q dx, and the direct value of this type of integral is given by this expression. So now we can see that here the integrand is only in terms of sine function. Here we do not have the cosine function, right? So here if we take q is equal to 0 in this integral, then we have the formula for this integral, that is 0 to pi by 2, and sine here we have x, here we have p, and dx. So we are taking now q is equal to 0, so that this term is equal to 1, right? Because we wish to evaluate this integral where the integrand does not contain cosine function, right? So here when q is equal to 0, we have gamma p plus 1 over 2, and here q is 0, so we have gamma 0 plus 1 over 2, that is gamma half, that is equal to square root of pi. So here we have square root of pi, and here we have 2 times gamma p plus q. Q is here 0, so we are simply having a p plus 2 over 2, right? So the formula for the integral 0 to pi by 2 sine x raised to p dx is given by this expression. So now if we compare this integral with this one, then the value of p is equal to 10, right? So here we can also apply directly the Wallis formula, right? But here we'll prefer this one. So here we have 4 times the gamma function, p plus 1 by 2, so 10 plus 1 over 2. Here we have root pi, and then we have 2 times gamma. uh, Here we have 10 plus 2 over 2. So now let us simplify it. So here we have 2 times 2 is 4, and here we have 2, and then we have here square root of pi, then we have gamma 11 over 2, and here we have gamma 10 plus 2 12 over 2 is 6. So now we have gamma n plus 1 is equal to n factorial. So here we have gamma 6. Gamma 6 is gamma 5 plus 1, that is equal to 5 factorial, and 5 factorial is 5 times 4 times 3 times 2 times 1, that is 20. Here we have 60, and then we have 120, right? And here we have gamma 11 over 2. Now a gamma 11 over 2 can be simplified by using this result: gamma n plus 1 is equal to n times gamma n, right? So here we can split 11 over 2 as 9 over 2 plus 1. So now we have this form, that is gamma n plus 1. Here n is 9 over 2. So using this result, we have 9 by 2 and gamma 9 over 2, right? So now we can again split 9 over 2 as 7 over 2 plus 1. So here we can now apply this result. So we have 9 over 2, and here we have 7 over 2 and gamma 7 over 2. Now 7 over 2 can be written as 5 over 2 plus 1. So applying again this result, we can now write gamma 11 over 2 as 9 over 2 times 7 over 2, and here we have 5 by 2 times gamma 5 over 2. And similarly we can split 5 over 2 as 3 over 2 plus 1, and 3 over 2 as half plus 1. So here we have now 9 over 2 times 7 over 2 times 5 over 2, and here we have 3 over 2, then we have half, and gamma uh, that is half, right? So we have now 9 times 7 times 5 times 3 times here we have gamma half, that is equal to square root of pi, and in the denominator we have here 2 raised to 5, that is 32. So now the value of the integral I can be written as here we have 2 root pi, and then gamma 11 over 2 is given by 9 times 7 times 5 times 3 times square root of pi over 32, and here we have gamma 6, that is 1 over 120. So now here we have 3 times 40, here we have 5 times 8, then we have here 2 times 16, right? So the value of the integral I can now be written as square root of pi times square root of pi is pi, and here we have 9 times 7 is 63, and here we have 16 times 8 is 128. So the required value of this integral I is given by 63 pi over 128, right? So viewers, by the application of this property of definite integrals, we can easily evaluate integrals of these types.